Let's build a galaxy. We live on a planet in a single solar system inside a large galaxy made up of 100 billion stars. A supermassive black hole equal to the weight of a few million suns anchors the center of our galaxy. Our universe has hundreds of billions of galaxies, each containing stars like our sun. Galaxies range in size from ones with 1,000 stars to ones with 1 trillion or more stars. That means we have a lot of places to explore. Edwin Hubble was one of the first astronomers to discover that our universe isn't just sitting still, but it's expanding. Hubble also grouped galaxies by how they looked, because not all galaxies are the same. He described a few distinct types. Elliptical galaxies, which have no easily defined shape, with stars that move chaotically, and spirals or disk galaxies, which are flat, with pinwheel spiral arms that spread out from the center. As Hubble began to classify galaxies, he quickly discovered many galaxies didn't fit neatly into his categories. Was it possible that galaxies change from one type to another over eons? Even our own Milky Way galaxy has been changing. There are a handful of smaller galaxies, such as the Magellanic Clouds, Fornax, Sculptor, Leo, and others that orbit around us. The powerful gravity of the Milky Way affects these nearby galaxies, either causing them to be ripped apart or pulling them in to merge with ours. Astronomers can tell if a star has invaded from one of these nearby galaxies if it lacks certain elements that are formed by many generations of star birth and star death within the Milky Way itself. The Milky Way has been a star factory for about 10 billion years. Generations of stars have fused hydrogen and helium gas to heavier elements such as metals within their cores and then spewed these metals out into the galaxy. This process enriches the gas and promotes the future generations of stars, like our own sun. Many of the stars in the galaxies around ours do not have the heavier elements in such abundance because of their different history. So we can tell which stars originated in the Milky Way and which ones joined our galaxy later. The Milky Way and its nearest similarly sized neighbor, Andromeda or M31, are part of the local group of galaxies. They're pretty close to each other. Only about 10 galaxy links separate the Milky Way and Andromeda. And when they collide in 4 billion years, it will be spectacular. We can simulate the collision of the Milky Way and Andromeda galaxies and predict that it should lead to a great deal of new stars and a whole lot of galactic chaos. Eventually, the two galaxies will merge into a single galaxy, which will settle down into a larger Milkdromeda galaxy. But don't worry. The stars within the galaxies won't collide. Galaxies are made up of mostly empty space, and the stars within them are very spread out. But the gas that surrounds the stars and forms them will collide spectacularly. Many galaxies are in the middle of a collision today. These type of galaxies are the ones that would not have fit into Edwin Hubble's categories. Irregularly shaped spirals, merging and distorting arms winding in strangely beautiful shapes. The exquisite detail of these types of collisions can be studied in a new light with NASA's James Webb Space Telescope. See those blue galaxies in this picture taken by the Hubble Space Telescope? Those are star factories, making stars at a much faster rate than the red ones. Webb can track the production of the heavier stellar elements in ways that no previous telescope could. Webb's infrared eyes can see through the dust in the galaxies to more clearly study the formation of new stars. While stars within the galaxies are spread out, the galaxies themselves tend to clump in nodes where gravity draws matter together. Galaxies are connected to each other by web-like strands of gas and dark matter. Galaxies most often form where the dark matter strands intersect. This cosmic web is the scaffolding that supports galaxy formation. Dark matter is 5 times more abundant than visible matter in the universe. Astronomers have simulated the spiderweb of dark matter by using the visible distribution of galaxies today. But Webb will allow us to see farther into the distant past, to galaxies just after they were first born. During this earlier time, the universe was hotter and denser, and many more stars formed in the early generations of galaxies. We're already late to the party. The best time for making stars was about 10 billion years ago. With Webb, we can look back to the early days of galaxies and stars and follow the trail of clues to understand the formation of these heavy elements, carbon, oxygen, nitrogen, silicon, and others that make life possible today. Webb will also allow us to study the collision of early galaxies and give us new clues about the invisible but dominant dark matter in the early universe. And maybe one of those spirals out there in the distance, back in time about 10 billion years, could be a mirror image of our own Milky Way looking back at us.